Hi all, welcome to Dell Boomi API Management Session 2. I'm Shalini Nerella. In our session today, we shall have introduction to OAuth 2.0. We shall then discuss how OAuth works, the different OAuth flows with examples, what is OpenID Connect, and we shall then implement the same in Boomi using external authentication type OpenID. Right? So let's first start with OAuth 2.0. So in order to access any application, you should first be authenticated, correct? One way to do that is to provide a valid username and a password. So, the one problem here is it becomes difficult to remember the password, and also the password can be easily hacked. So, the users usually want something advanced, something beyond this, correct? And now talking about Yelp. So for those who doesn't know what Yelp is a social networking site that lets users post reviews and rate businesses. Businesses like restaurants, dentists, bars, beauty salons, doctors, etc. Say when you go to a new restaurant and you have a good experience, it is likely that you won't keep that place a secret. Instead, you go and rate that in the Yelp. Clear? So, way back when Yelp was a new brand app launched, I guess it is around 2004. It showed this pattern to find if your friends are already on Yelp. So, it asked for email address and password. So, it asked for the email address and also password so that they can get access to contacts. But just imagine, would anyone share their email password to any application as such? For sure, they don't, right? But right then, it was the only way to do this. So not only Yelp, there were many other applications that were doing this. So here, Yelp actually needs only the contact information, but with password, you are giving the complete access. So there should be a way for an application to access only a part of your information without actually giving it your password, right? So, as the API is then becoming popular, and this process of authentication by asking password, making it difficult for applications and also for users, the developers came together and formed this something called OAuth, an open standard for authorization. This has come into picture around in the year of 2006. Clear? So, with OAuth then implemented, Yelp login screen looked something like this. If you see this, it gives you option to sign in with Apple, Facebook, and Google. Say you signed in with Facebook. So it would open a consent page like this. And here, if you see, it is providing access for help to get information from Facebook. So if you say continue, you are giving access for help to get the information from Facebook or for Facebook to send information to Yelp. So you are trusting Facebook here and you are logging it with its credentials. Clear? So this is how an app is authorizing other app and sharing the required details with the help of OAuth. So this is all from user's perspective. Now let's see how the app is accessing the other app and how is it able to get the data. So let's see how OAuth works from application point of view. Okay. The goal of any app is to get the access token, which is the key to access an API. So how it gets this access token will be dependent on what kind of app it is and where it is running. So there are different OAuth flows that determine how you get the access token. So talking about implicit flow. In this flow, an access token will be returned immediately without an extra authorization code exchange step. And this is less secured as it is returned as the access token is returned within the browser. Okay. And then authorization code flow. With this flow, we get an access token and also a refresh token optionally. We generally use this when client is a regular web app executing on a server. Then password flow. In this flow, the end user is asked to fill in credentials, typically using an interactive form. So the credentials like username, password, etc. and this information is sent to backend and from there to the authorization server. Then client credentials flow. This is more of like mission to mission authorization. So here the client itself is also the resource owner, so there will not be any end user authorization required. For example, consider a cron job that uses an API to import information into a database. In this example, the cron job is the client and also the resource owner, since it holds the client ID and client secret, and it uses them to get the access token. Clear? Then OAuth providers. So here in this link you can find the list of OAuth providers available, and the best among them are Google, Facebook, and also you can try Amazon and Microsoft. All four of them are big and easy to integrate with. So Facebook provides instructions for registering an app, and Google also have the similar steps. So the basic idea here is that you create a developer account and then create an app ID. So the provider then gives you a client ID that you can use to make the request. Okay. And so let's see some terminology related to OAuth. The user here is called the resource owner. The device is also known as the user agent. The application is called as client as well. The OAuth server is also known as the authorization server, and the API is known as the resource server. Okay. Then we have different channels like called front channel and back channel. So front channel is where the data is sent via the browser's address bar. So anyone can easily tamper that data. And back channel is where the data is exchanged securely between the client and the server. And since it is using HTTPS request, the data cannot be tampered. And the response from the server can be trusted because it comes back in the same connection. Okay. Then we have two different types of clients, public client and confidential client. Public clients are where the application can't keep strings a secret. For example, the browser-based apps, mobile apps, they can't keep the strings a secret, right? And confidential clients has the ability to keep strings a secret since the code is running in a trusted environment. Okay. Then tokens known as reference token and self-encoded token. Coming to the reference token, here the token itself is a random string and it points to a record somewhere else. The simplest example is storing token in a database table. And self-encoded token. So here the data about the token lives inside the token with either signed or encrypted or both. So if you're building an app, you're not bothered if it is a reference token or a self-encoded token. But if you're building an API, you're going to receive the token and somehow you need to extract the data. So then you'll be bothered about which token it is being used. Okay. So along with the provider's login URL, you need to send some URL parameters that tell the provider who you are and what you want to do. Okay. So some of them are like client ID. So this tells the OAuth2 provider what your app is. Remember that you'll need to register your app ahead of time to get this client ID. Then we have the redirect URL. So this tells the provider where you want to go when you're done. For a website, this could typically be a main page, right? Then response type. This tells the provider what you want back. Normally, this value is either token to indicate that you want an access token or a code to indicate that you want an access code, right? Then scope. So this tells the provider what your app wants to access, say like photos, contacts, etc. So each provider has a different set of scopes. Clear? Then let's now see some flows with real-time examples. Please note that the examples that I'm giving here are only according to my understanding. I'm really not sure if the application is using the same flow for authorization or not. Okay, so let's first start with implicit flow. Let's say you wish to listen to latest music and so you wanted to sign up to Spotify, right? So you as a user from your device will click on sign up. You're saying would like to sign up to the app. So the Spotify application then sends this saying that please go to any of these authorization servers and grant me access. right? So you have the Facebook account and so you wanted to sign up with it. So you click on sign up with Facebook option. So then a request will be sent to the authorization server with this information. So you'll be having the response type, the client ID, the redirect URI, scope, state. So with this complete information, you are sending the request to the Facebook server. So Facebook then returns something saying, I will send your name and profile picture to Spotify if you are okay. So when you say continue, you will see that an access token is being returned in the browser. So when you accept, an access token along with expires in and state will be sent in the browser. And when you reject, an access denied error will be shown. Clear? So then this access token will then be shared by Spotify application to the resource server with the scope in it. So then the resource server will share the required resources to the Spotify application. Clear? So let's see a real-time example. Let me go to the browser and say www.spotify.com. So here you can see sign up option. So here sign up with Facebook. When I click on this, you can see this is redirected to Facebook authorization server. Let me copy this URL here and I will log in with my credentials and say login. So now you can see the URL that is being exchanged. So see here, I'm successfully logged in. But if you see here, the access token, data expiration time and expires in is being shared in the browser. See here, the access token you can see in the browser. Right? So this is implicit flow. As per my understanding, this is implicit flow. Okay. So going back, let's now see at a high level what is happening. So you as a user sending a request to the Facebook authorization server and Facebook then gives you the access token. So you are sharing this access token to the Spotify application server and the application server is sending the access token to the resource server. Resource server then shares the music files to the Spotify application. Clear? Yes, so that's about implicit flow. Let's now talk about authorization code flow. So as said, there will be an access token and also refresh token here. So this is unlike implicit flow, this is secured because the access token is not returned in the browser. Also, we have two channels here, front channel and back channel. So in the front channel, if you see, consider taking an example of PixArt. So again, you would like to log into the app. So the app asks you to authorize with any of these authorization servers. So when you click on login with Facebook, a request is being sent to the Facebook authorization server, and it will then ask you that PixArt will receive the name and profile picture. When you click on continue here, the authorization server returns a temporary code to you. Okay, a temporary code is returned here. See, and if you reject, access denied error again. So this temporary code you'll be sharing it with the PixArt's application server. Okay, so then the PixArt application server sends this temporary code with a client secret which it already has to get the access token from the authorization server. Okay, so this is all the back channel process that is happening, which will not be seen in the browser for us. Okay, so this is the request that will be sent to the authorization server. Authorization server then returns the access token to the application server with this information: token type, expires in, access token, scope, and refresh token. Right? So this is in case of an error. So the application server with sends that access token along with the scope to the resource server. So the resource server then gives access to that requested resource. So let's now see an example. Let me go to the browser and say pixart.com. So say sign up here, sign up with Facebook. So see here, this is the URL. So let me copy this here again. I'll share my details here and click on login. So you'll see none of the information is shown to us. You are directly logged in, but none of the other information is shown to us. Correct? Because that is all the back channel that is happening. Clear? So this is how the authorization code flow works. So let's see what is happening at a high level here. So you again have sent request to the authorization server. You have got the temporary code here. So the temporary code is then shared to the Pixart application server, and the Pixart application server shares this temporary code along with the client secret that it is having to the authorization server. So authorization server then sends the access token to the application server. So this access token is then shared to the resource server. The resource server then shares the required resource to us. Clear? So in this flow, your application is getting an access token which is having access to the application claims, and that access token is used to access a protected API, but it doesn't have any information about the user. It is not aware of who the user is. Correct? So this can very much be compared to a hotel key card. You give your ID card to the person at the front desk and she shares you the hotel key. You swipe the door with the key and it opens. It is not bothered about who is using the key. It only minds if the key has access to this door or no. And that decision is made by the person at front desk. So this is the analogy of OAuth. But in few cases, the API needs to know who the user is. And the API needs to know who the user is. Correct? So here OAuth can't help at all. It doesn't do anything here. So we need to have something beyond OAuth, which is known as OpenID. So with OpenID, your application receives an ID token along with code. And it is the responsibility of your application to verify your ID token. Since the ID token is being verified here, it makes OpenID an authentication protocol. And OAuth, since there is no validation, it is called authorization protocol. This is very important. Just understand this. Because you are being verified here, OpenID is called an authentication protocol. Since there is no validation at all in OAuth, it is called as authorization protocol. Clear? So let's now see one example with OpenID Connect. So here again in front channel, you're saying you'll want to log into this application. So here we are accessing Zomato application. Okay. So when you say when you click on login, here again it asks to sign up with any of the authorization server. So then a request is again sent here to the authorization server. But here you can see the scope you're sending here as OpenID, profile and email. Okay. So then it says application wants your user profile information. Is that okay? So when you click on OK, a temporary code is again sent. So like this. And this temporary code is exchanged to the application server. Application then shares the temporary code along with client secret to the authorization server to get the access token. So you can see this information is being will be exchanged. Then this time the authorization server returns access token, also ID token. Okay, so this ID token gives the information about the user. See here, it looks something like this. So the access token and ID token as well, the scope. Clear? If there's an error, it shows this. So this access token and scope is being shared to the resource server, and resource server will then give the requested resource. Clear? So let's see how this is working in real time. I'll go to browser and say zomato.com, and I'll say login. So here you can continue with Google or email. So when I say continue with Google, so this is the data that is being exchanged. And when I click on this, you will see this. So here you can't see any access token or anything because that is happening that in the back channel. But this is the URL that is being exchanged. You can see here the response type is ID token. You're sharing the client ID information, etc. Clear? So this is how the OpenID Connect works. So let's go back here and let's see what's happening at the high level. Uh, you've sent a request to the authorization server. Temporary code is being shared. So you share that code to Zomato application server. The code plus client secret is exchanged to the authorization server. So here now authorization server shares the access token plus ID token. Okay. So the access token then shares it to the resource server. So then you get the required information. So this ID token here identify who you are. So that is why we are using OpenID Connect, and this reference to that user makes it different from the OAuth. Okay, is this clear? So let's now see how to set up OpenID authentication in Boomi. Let's go to Boomi. So let's set up an external authentication source using Google OpenID. The reason we are going for Google OpenID here is because we all have Google accounts and it is easy to set up, right? But please make a note that Google does not send the authentication token to localhost. We should have a public URL available that is accessed outside of your internal network to receive the token from Google. Clear? So what I have done here is, this is my external authentication. This is my broker. So as you all know, broker is a runtime that hosts the authentication sources for an API-based solution. So when setting up the broker, you can set up the authentication source with it. So this is a runtime that hosts that service for you. Gateways interact with broker to authenticate the user. This is the backend runtime service that does all the backend processing. Clear? So I have set up a free tier EC2 instance on AWS and installed a gateway and a broker on it. So I've already done the broker settings here. So if you see here, this is a public DNS that has been added to the public URL and the public IP address that is added to the cluster nodes. So Google can now send the token to this publicly available URL from AWS. Clear? So let's now add the authentication source. I'll go here and say add authentication source. So if you can see here the different identity provider types we have. So one of them is OpenID Connect. Clear? So I have already set this up. This is the OpenID authentication we have. So this is the source configuration for OpenID. Here you can review and modify the properties of your external identity provider. As discussed, the external identity provider we have chose here is Google. So before setting up this further, let's go and first set up the Google OpenID. So I'll go here to console.developers.google.com. So we are setting up the Google OAuth ID here. I'll go to credentials. So as said, we first have to create an app and then register that. So this is my project, and in this, if you see, create credentials. Over here, you can find the OAuth client ID. See here, requests user consent so your app can access the user's data. Clear? So let's first go and create the OAuth client ID. So here, select your application type. I'll select web application and I'll give the name as Boomi OAuth app. Okay. I'll just say create. So here you can find the client ID and client secret. I'll just say okay. So this is now created, right? So now if I go here, these are the general settings. So you can give the source name, the description. You can attach the broker here. And these are the different flows that are available. So authorization code flow, as we've discussed, it is used to obtain both access token and refresh tokens. So this grant type is usually used for confidential clients, and implicit flow is used to obtain the access tokens. So this grant type is usually used for public clients known to operate a particular redirection URI. Clear? So then after you configure the authentication source, you can test the connection to the identity provider by clicking here on the test identity provider configuration. So testing the identity provider allows you to verify if the connection is set up properly or if there are any errors. Clear? So if you want to say if you want to know which all APIs are deployed with its authentication source, you can do that with API associations. So if I click this, this opens the API associations panel, and this lists out all the deployments for that authentication source. Clear? Then identity provider. So here you can give the alias name, and here you can provide the authentication URL, token URL, and etc. So these all are constants for Google. So you can just make a note of this. You can just paste them here directly. Okay, the authentication URL and token URL, logout URL, user information URL, all these are not required. And client ID. So I'll go here and copy my client ID. So copy this client ID. I'll copy this and paste it here. Then copy the client secret. And paste it here in the client secret. Say apply. And issuer is not required. Default scopes we can provide here as OpenID, right? Prompt type not required. And remember, copy this redirect URI here and paste it here in the web app, the redirect URIs. So just say save. So this is now done. Okay. So then we have roles tab here. So you can use the roles tab to identify and associate the roles from your third party identity provider into the authentication source. Enter the group identifier from your identity provider here. So the group identifier is the name of the claim in which the identity provider stores group membership information. Okay. Once the group identifier is set, use the values in the claim directly as the identity provider roles. Clear? Fine. So let's now go and test this first. I'll click on test identity provider information. So you'll have to first save this. I have saved it. And now say test identity provider. So see here, it opens the consent page for me, right? So let's see the URL exchange here. OAuth with scope as OpenID. See here, scope OpenID and state is being passed. So now when I click on this, so this you can see authorization code received, right? And here you can see, and you can see here the identity provider successfully sent the authentication token. So let's now change the authentication type for developer portal settings. So I'll go to gateways here, open the gateway, developer portal settings, and the authentication source currently is basic authentication. So I will select OpenID authentication. Fine. And also remember we need to provide the public URL. So I'll go to broker here, broker settings. I'll copy this public URL. Okay. So let's paste the public URL here and change this to 18077 and save it. So this is done. Let me open a new private window here. So just to make sure that the details are not cached. 18077. Okay. So see here, this opens the API developer portal. Okay. So all good. Just say sign in. So see here, it asks for the consent page and I'll give my credentials here. See here. So now I'm able to access the applications here. Right? I'm able to view the API catalog. This is how the OpenID authentication is working for the developer portal. Okay, so this is all good. And now let's hit the same using Postman. Uh, I'll go here. I'll go to deployed APIs. APIs by gateway. So I'll change the authentication type for this to OpenID. So save this. So if you see this, let's first see what this process is doing. So I'll say view the API in Boomi integration. So just see what this process is doing. See here, it's a REST call with a get action, and this is the process. It just take the request and prints hello. Okay, so this is a simple process. So it's a get action and it just prints hello. So I'll close this, and this is my endpoint, right? I'll copy this here, and authorization, let's select OAuth 2.0. So let's say get new access token. I'll give the name here as Boomi OAuth token. And so for all these details, what we'll do is we'll go to Boomi here, and if you go here, you'll be able to find this authentication URL. So I'll copy this and paste it here, right? And this is the token URL. Copy this and paste it here. Similarly, the client ID. So that's it. And grant type authorization code. So I'll uncheck this and say request token. So see here, Boomi OAuth token. And you can find here the access token, and here expires in, refresh expires in, and here the refresh token, token type bearer, and ID token. So this is what the OpenID is returning, the ID token. So this is the identity of the user. Okay, and add token to header. So I'll say use token. Okay, so see here, this has been added here, and now we'll also have to add the API key. So I'll go to applications here, uh, open this, copy this API key, X API key, and paste it. So all good. Let's say send. See here, it prints hello. Clear? So this is how OpenID authentication works in Boomi. Let's go back here. So this is a sequence diagram for OpenID. Basically, we have two flows here. First flow is for getting the token, and then from there we are passing the token to the request, right? So first, let's start with getting the token. So remember that we have different flows like implicit flow, authorization code flow, SAML. So each one of them differs in getting the token. This is the simple example that we are considering. Okay. Basically, the apps get the token, they pull the token to see if it is expired. Then they send it to login to the broker through the authorization server URL. Clear? The IDP then gives the consent page, and when you approve it, a code will be shared to the broker. You exchange that code to the IDP and get the token, right? So we receive a token. The time to live here is, in this case, is 5 minutes, but it totally depends upon the identity provider. Okay. So now that we have a token, you can make an API call to the gateway with the bearer token and the API key in the header. Okay. Remember, API key is required in every request. Okay. Basically, gateway will take that message and then send it to the broker to validate the token and policies. Right? If it is a valid response, it is going to return a redirect call from gateway itself to the backend runtime, like it can be atom or a molecule. So here it is going to validate the auth header and a logic of the actual integration process and returns the response to the user or application, whoever it is. Okay. So this is a very good application provided by Okta for OAuth 2.0, where you can play around different flows. So you all can just have a visit to it. So that's about the end of the session. Thank you.